Hello friends, welcome to the lockdown classes. As we have discussed earlier about the velocity and its direction, we will here retrace our statement and we will try to prove that our statement are valid for all the reasons and all the situation. So specifically for this vertical situation we will be seeing the uh, for this vertical situation we will be seeing the case. Hello. Okay, fine. So here we have seen that when we have given initial velocity to an object, okay, v suppose, and this is our axis from where we have given the velocity. It will go in the positive y direction, and it will decrease gradually till it's become 0. Okay, why it is decreasing? Because the acceleration, that is force due to the earth here, which is always acting towards downward, is acting opposite to the velocity. So we know when the force is acting opposite towards the direction of the velocity, it will decrease the speed. At the top, you will tell me what is the direction of acceleration at the top. Okay, this is the question. Okay, when after reaching the top, the direction of the velocity is negative, towards negative y direction, it is coming downward, and at here also the acceleration is downwards. Now it is supporting the velocity. When the direction of acceleration is supporting the direction of velocity, it will increase the speed. So suppose you are standing here and the rock falls above your head, you will experience a good quantity of force with a great kinetic energy because of the increase in the velocity. Okay, so the force always acting and supporting the velocity depend on the direction of the velocity. So according to our statement prior, we have seen that we have proved our statement that the direction of the displacement tells which side the object is. Okay, direction of the velocity tells the which side the object is going. It is going in positive y direction. From your reference frame, you will always take the reference frame, and the direction of the acceleration tells you which side the object is experiencing the force. Okay, now let's go into the next topic. Here we give the representation of the theta with respect to our statements. So when the velocity and force are acting in the same direction, the angle between them is same, so 0 degree angle is making. So it's the angle is 0 degree between the force and the velocity, or you can say between the acceleration and the velocity. So acceleration and velocity making the 0 degree angle will give you the increase in the speed. This is speed. The speed will be increased and there is no change in the direction, no change. When the force, this is the braking part, this is the acceleration part of the vehicle. Okay, this is the braking part of the vehicle. When the force or acceleration and the velocity is in opposite direction. Okay, whenever you apply brake, you are actually accelerating the object in reverse direction. There was also a situation in Mission to Mars, you have seen in that movie, that the spacecraft when orbiting inside the orbit of Mars, it has greater velocity, so they give an acceleration opposite towards the direction of the orbiter to slow its speed, because it was acting to the point of incidence of the Mars orbit with a greater velocity. So to decrease the velocity, they give the acceleration in opposite direction. So you can see that in Mission Mangal movie. Okay, so this was the great example that has been shown there. The applying of acceleration in the reverse direction actually slow down the velocity. Okay, so it will slow down the speed or velocity, you can say, with the no change in the direction, but that was circular motion, that is to be pointed. So here we have seen that if you apply velocity in the perpendicular direction of the force, it will actually change the direction in the force at some common point. So in a circular motion case, for a circular motion case, you will see that when an object is moving in a circular motion, the velocity and the force, this is velocity v, this is force f, they are acting at perpendicular direction, and at every point it will acting perpendicular direction. At this point it is acting perpendicular direction, at this point it is acting perpendicular, means towards the center. At this point velocity and force, so the object will take the shape of circular motion, and it will go in the form of circle. So when the angle between the force and velocity is 90 degree, it actually changes the direction. Now this is important. This change in direction will only happen when the angle between the force or acceleration and velocity and acceleration, force is acceleration, direction of the force is the direction of the acceleration, okay, is actually 90 degree. Okay, so for the case 1 you have seen, when you push someone, it will actually increase the speed, and it will eventually the person will fall down if he is an old one. Okay, so important note is that at same axis there is no case of direction change. The case of direction change is only when the axis is perpendicular. I have shown you in above examples. So when the angle is 90 degree, mathematically only that case is referred as a direction change, as the body has deviated from its path. When the body is on same axis, it will not consider as a direction change. Okay, direction changes if axis changes, that is like from x to y or z. So there are 3 axes in 3D, you know about it, that is x axis, y axis and z axis. Okay, from any change from one axis to another axis will be considered as a direction change. So when you apply force in opposite to the direction of the velocity will decrease till it becomes 0. Okay, and from the case 3 you have seen, whenever you are moving in a vehicle, okay, you have seen that the force when you are banking or along the road, you are moving in a particular direction v, the direction of the velocity, and the force acting will be perpendicular, and the direction of the acceleration will be perpendicular to the direction of the velocity, tangential direction of the velocity, and there is a subjective force, so it will move in a circular direction. Okay, circular motion. Here friction is also acting. Okay, so that is why there is banking of roads also. The roads are banked to actually maintain the geodesics at angle theta. Okay, so here the angular representation can be represented as, this is the body, okay, and this is the banking. So the road is banked at the angle theta, at which your body will also bank, always be turning towards the center, because your body is experiencing force towards the center of the motion of the circle. Okay, so here it's written, see, force is inward in the radius perpendicular to the velocity, that is tangential to the curve. So there are 3 types of forces you have studied. One is, there's actually 2 types of forces, one is contact force and one is non-contact force. Contact forces are the forces like friction or mg or the tension due to the body. They are the actually contact forces, means their body is actually in touch with the another body. Okay, so for tension force, the object mg that is acting downward is balanced by the tension, there is actual point of contact here. For friction force, so if you give force in positive direction, there is a friction between earth or ground and the body, that is represented by small f in the backward direction with the point of contact. So these are contact force. All the forces of free falling object like gravity or electromagnetic are non-contact forces. So you have seen the example of gravity above, the motion of vertical motion, the example of vertical motion. Okay, so we have seen that the circular motion I have explained you, the force at the center is called as centripetal force. Similarly, to balance this centripetal force, now this is an important discussion part. To balance this centripetal force, action reaction, is this action reaction pair? You will tell me. There is a force outwards. Okay. Now this force is called centrifugal force. See, you can see the man here. So if you are here, suppose you are sitting on this ball, and if suddenly this rope cuts down, you will experience a force in the outward direction, and you will go away from your center and you will fall apart. You have seen the case of merry-go-round where that you have seen in that park where these okay, so if you go round and round in a merry-go-round in certain park, you have seen these kind of apparatus, these kind of swing machines, and you have seen that if you suddenly pull off your hand, you will fall apart from the center of the body. So we will explain this part of centripetal force and centrifugal force, and this centrifugal force is a pseudo force. It's actually not there. It seems to be there, but it's actually not there. It feels like you're experiencing a force, but what you feels is actually the acceleration. Okay, and you will tell me if this is an example of action reaction force. Is this centripetal and centrifugal force is an example of action reaction force? You will tell me in your comments. Thank you.